All right, so for these problems, we're going to be expressing one variable as a function of another variable. Whenever you hear express something as a function of another variable, it means get this variable alone in terms of only the other variable and constants. So in this case, express g as a function of w means get g alone in terms of w's. So to do that, we need to get this g isolated. We'll start by subtracting this 5w to the other side to get 6g equals negative 5w plus 12. You can write 12 minus 5w, but it's a good idea to order by exponent as a general rule. At this point, we want to get g alone. To get g isolated, we need to get rid of this 6. Since it's being multiplied, we are going to divide each side of the equation by 6 to leave us with g equals negative 5w plus 12 over 6. And it's perfectly okay to leave it just like this because this doesn't simplify at all. But some of you might be more comfortable seeing this as two separate fractions. So whenever you are adding or subtracting in the numerator, you can break it up into two fractions being added or subtracted, which means you could rewrite this as g equals negative 5w over 6 plus 2, or negative 5/6w plus 2. There are a lot of ways to go through this, but I'm going to stick with this first way because it's a lot cleaner and it works a lot better as you go further into mathematics. So going back to this example, now that we have g alone in terms of only w and constants, g is now a function of w, so we can say instead of g equals negative 5w plus 12 over 6, we can now write f of w is equal to negative 5w plus 12 over 6. Since g is a function of the variable w, it can be rewritten as f of w. So with that in mind, let's try this next example together. This one shows a little bit of a tricky thing that can happen with these types of problems that you need to be aware of. If we begin expressing y as a function of x, that means get y alone. We'll subtract x squared from each side of the equation to get y squared equals negative x squared plus 1. To get y alone at this point, we need to apply the square root function to each side of the equation. But when you apply the square root function to each side of the equation, you have to account for the fact that there was a positive and a negative root. So we get y equals plus or minus the square root of negative x squared plus 1. At this point, it's very tempting to say y is now solved for in terms of only x and constants. But there is an issue. Remember that a function cannot have repeated x values. So let's test a certain value here and see what happens. Let's test x equals 0. If x equals 0, we will have y equals plus or minus the square root of negative 0 squared plus 1, which gives us plus or minus the square root of negative 0 squared is just going to be 0, plus 1 is 1. So we have y equals plus or minus the square root of 1 is 1. The issue is if we write this as coordinates, we would get x is 0, y is 1, x is 0, y is negative 1. We have repeated an x value with different y values. That breaks the definition of a function. We've repeated a domain value, which means y is not a function of x. So we say y is not a function of x. Meaning you will not always be able to express one variable as a function of another. you need to be aware of this scenario. And in the next video, we're going to show how you can quickly test for these types of scenarios.